The implementation of technological processes in industrial enterprises includes welding operations. One of the most common types of these works remains manual electric arc welding, which is performed in many cases at stationary workplaces. Electric welding works are accompanied by intensive emission of harmful gases and fine dust into the production atmosphere, the qualitative and quantitative composition of which is determined by the type and consumption of materials used in the welding process. The main way to localize and remove harmful contaminants from the air of the working area is open local exhaust systems of various designs, which are the main elements of local exhaust ventilation systems. However, as practice shows, in many cases, the well-known designs of local exhaust hoods used at stationary welding posts are not effective and do not provide the required level of purity of the air environment. Real-world experience with the operation of various types of local exhaust systems has shown that their operation does not always guarantee an adequate level of air quality at welders' workstations. The main reasons for the inefficient operation of existing local exhaust systems of stationary welding stations are lack of reasonable recommendations on the choice of shape and size of local exhaust air intakes, the application in design practice of simplified methods for calculating the flow rates of the removed air according to the recommended air velocities in the air intake. In most existing designs of local suction systems, there are no screens, which allow, firstly, to protect the exhaust area from periodic or constant exposure to blowing air flows, which disrupt normal operation and sharply reduce its efficiency. Secondly, usage screens of various designs, it becomes possible to significantly reduce the required volumes of exhaust air. The performed analysis showed that the most important directions for improving the efficiency of local exhaust ventilation and ensuring normal sanitary and hygienic working conditions at stationary welders' workplaces are the use of shielded open local exhaust hoods and improving methods for calculating their rational structural elements and aerodynamic parameters. The parameters of the operation of local exhaust systems were determined by computational modeling, using a system of Navier-Stokes equations. The objective of the research is the air currents at the intake ports of local exhaust hoods for welding operations. Considering the efficiency of using screens to remove harmful particles entrained by heat jets, we propose an open local exhaust device with a side panel. At the same time, the shielding of the welding zone with airtight shields is provided. The schematic diagram of the proposed design of a local exhaust hood for welding tables is shown in Figure 1. Here, the side air exhaust is carried out through a uniform suction duct located directly above the long side of the work table. To reduce harmful suction, a vertical shield is provided, adjacent directly to the duct and to side shields. The latter are rotatable relative to the vertical axis, for convenience, when setting and removing welded structures from the table. Mathematical modeling was carried out to study the operating parameters of the proposed side exhaust design. At the same time, the operation of common existing designs of local exhaust systems was also modeled to compare the parameters of their operation. In the previously performed modeling, it was found that the efficiency of side exhaust hoods is less affected by changes in the location of the welding point in the plane of the table, and the use of general exchange displacement ventilation in addition to local exhaust ventilation is justified. The field of air flow velocities in the area of operation of the local exhaust system is shown in Figure 2. The concentration field of the welding aerosol in the area of operation of the local exhaust hood is shown in Figure 3. The analysis of the results shows that with comparable exhaust air consumption, the concentration of welding aerosol in the exhaust air of the proposed side exhaust hood reaches high values, which makes its use advisable. A design of a side local exhaust hood with shields has been proposed, the effectiveness of which has been confirmed during quantitative modeling of its operation. Additional theoretical studies are necessary to develop a methodology for calculating the flow rate of the removed air. The proposed design of a local exhaust hood is advisable to use for localization of welding aerosol in industrial enterprises, subject to the development of a methodology for calculating the volume of air being removed. Thanks for your attention.